Good morning, students. In this lecture, we are going to discuss categorical logic, or formal logic, or syllogistic logic, and so on. Categorical logic is a logic that deals with categories. Okay. Now, by categories, I mean any arbitrary way in which we can categorize or can group things into a class or into a category. As I said, we can do this arbitrarily. We can collect tables, pizzas, tools, televisions, babies, blonde people, Martians, and so on. We use Venn diagrams for categorical logic. Although Venn diagrams are not traditional ancient, they were invented by John Venn. We use Venn diagrams. We use circles. I'm sure you are familiar with Venn diagrams. They teach you these things in middle school, high school. At one point in your life, you know Venn diagrams. So each Venn diagram is each Venn diagram contains whatever we want. So we label it. For example, I have here blonde people, electronic devices, mammals. You can create a class, any class that you want. Each class contains certain members. Members there are decided by you. Blonde people will contain only blonde people, not anything else, but just blonde people. Similarly for electronic devices and mammals. I am able to make a statement about categories if I use either an X or I shade the area of the circle. Depending on what I do, whether I place an X inside the circle, like in this case that you can see here, or whether I completely shade the area of the circle, I mean different things. This is what the beauty of categorical logic is. So if I have a category, the category of blonde people, and I place an X inside blonde people, in logic, X has a specific meaning. It means some. And some is intended as at least one. So when I place an X inside the circle for blonde people, I mean that there exists at least one thing in that category, and that thing is a blonde person. There's at least one blonde person. So remember, this is very important. The X signifies existence. The X, as we will learn later, the X makes an existential assumption or an existential import. If I place the X outside, what do you think I mean? I mean that something exists which is not a blonde person. It's anything else besides blonde people. And if I shade completely the area of the circle, I shade it. Now, by shading, remember this, when you shade completely the area of the circle, it's like you're closing let's say you're putting a lid on it and nothing goes in. So it means what? It means there aren't any blonde people. So if you shade your Venn diagram, if you shade your circle, your container, okay, this is what they are. They're containers. If you shade it completely, you mean there aren't any members designated by this class. There's nothing at all. And what about shading on the outside? Well, shading on the outside means that whatever is outside the circle designating blonde people doesn't exist. So everything is blonde people. On the outside, everything else, babies, pizzas, beds, computers, don't exist. There's only blonde people. So the objects, people, animals designated by a category obviously have logical relationships with other categories. For example, I can say that blonde people are also human beings. I can say that blonde people are beautiful. I can say anything I want. So there are four ways to indicate a relationship between two different classes. These four ways are, the first one is that all members that are contained in a class of blonde people, for example, are contained also in the class of another class, on the class of something else. For example, blonde people and beautiful things. So if I say that all blonde people are beautiful things, I state what is known in logic as the A form. The A form says that all members of the subject, since every statement has a subject and a predicate, the subject will be blonde people, beautiful things will be the predicate. So I say that all the members of the subject are inside the class of the members of the predicate. The second way that I can connect these two categories is by saying that no members, this is not actually a connection, it's disconnection, because the E form says that no members of the class of blonde people are also members of the class of beautiful things. The I form is the third form. That states that some members of the class of blonde people are also members of the class of beautiful people. Only some. And the fourth and last categorical form is the O form, which states that some members of the class of blonde people are not members of the class of beautiful things, assuming that we're using as an example blonde people and beautiful things. So these four classes can be represented by using Venn diagrams. Before I show you how to represent A, E, I, and O using Venn diagrams, let me explain something about the logical areas. Now, as you can see, these two circles, each one represents a term. So the first one would be the S, the subject. The second one would be the predicate. So let's go with the example of blonde people and beautiful things. If I want to say the four statements that I said earlier in a previous slide, all blonde people, namely, okay, number one, all blonde people are beautiful things. Or number two, no blonde people are beautiful things. Or number three, some blonde people are beautiful things. Or number 4, some blonde people are not beautiful things. So these 4 forms are A, E, I, and O. All of them, none, some are not. But in order to make these statements, which are very useful to us, when we represent these statements using Venn diagrams, naturally, as you can see, we have to overlap 2 circles. By overlapping 2 circles, we signify that the subject and the predicate are related somehow. And by shading and using X's, we clarify what exactly is this relationship. So before I show you the 4 forms using Venn diagrams, let me explain something very important that you have to understand before we move to that point. When you overlap 2 circles, you, as you can see, you create 4 logical areas. Not to be confused with the 4 logical forms, okay? I know that this might sound confusing, but there are 4 logical areas. 1, 2, 3, 4. As you can see, logical area 1, which is this one, it ends right here. It ends right here. It's it looks like an apple that someone took a bite off it. Logical area 1 is the logical area that contains, again, let's go with blonde people and beautiful things. Logical area 1 contains only blonde people that are not beautiful. Area 2, on the other hand, as you can see here, area 2 is this eye-shaped area. In area 2 contains only blonde people that are beautiful. Now, how many blonde people that are not beautiful are contained in area 2? Think about it. 0, not even 1. They're all here in area 1. So if you are blonde and you're not beautiful, you live right here in area 1. If you are blonde and you are beautiful, you are right here in area 2. How many beautiful blonde people live in area 1? Again, 0. They're all here in area 2. What about area 3? What's inside area 3? Who or what lives in area 3? In area 3, you are going to find only things that are beautiful. Beautiful puppies, beautiful apples, beautiful cars, beautiful anything that is beautiful but is not a blonde person. How many blonde people? 0 blonde people. What about here in area 2? How many beautiful cars are you going to find here? 0, not even 1. And what about 4? Well, in area 4, naturally, you will find everything else. Things that are not beautiful, things that are not blonde, everything else. Okay, now let's use Venn diagrams to represent the 4 categorical forms. Remember, the 4 categorical forms are A, all SRP, E, no SRP, I, some SRP, and O, some S are not P. Okay, let's start with the first one, the A form, sorry. Notice what I had to do in order to represent the A form. I had to shade area 1. Remember, this is area 1, 2, 3, and 4. Now, why do I shade area 1? It sounds awkward, it looks awkward, but it is necessary. Because if I don't shade area 1, then if S is blonde people, and P is things that are cute. Essentially, what I'm saying is that all blonde people are cute things. I'm sorry. What I say if I don't shade, if I do shade, I say all blonde people are cute things. If I don't shade it, shade area 1, what happens is that I leave room for blonde people that are not cute. But that's not what I want to say with the A form. My categorical statement says, in the A form, says that all blonde people are cute things, beautiful things. Consequently, I have to eliminate all the blonde people that are not beautiful. I'm not going to kill them, but I'm going to shade area 1, because in area 1 is, remember, area 1 is the one where blonde people who are not beautiful live. So by shading it, I mean there's nothing here. All those blonde people who are not beautiful don't exist. Everything that exists is the overlapping portion, which contains all the blonde people who are beautiful. The next form is, as you notice, I shaded completely area 2. Area 2 is the overlapping area, is the area where the two classes, when overlapped, share some members. But by shading it completely, I mean that no SRP, or no blonde people, are beautiful things. So that's, by doing this, I completely isolate the two classes. And in one class contains all the blonde people. The other class contains all the things that are beautiful, but there are no members in common. So blonde people, essentially, according to an E form statement, blonde people in this case are not beautiful, not even one. And beautiful things are not blonde people, not even one. The third form is the I form, that states that some blonde people are beautiful things. So not all. In order to say all, remember, we had to shade area 1. In order to say some, since we are talking about some, at least one, remember, I use the X. Where I place the X? I place the X right in the middle in area 2, because I want to say that some members of the class of blonde people are also members of the class of beautiful things. Now, when I place an X right in the middle, as you can see, I form this symmetrical figure. So when I say that some blonde people are beautiful things, I, by necessity, say also that some beautiful things are blonde people. The fourth and last form, logical form, is the O form, that states that some blonde people are not beautiful things. In order to indicate that, in order to make that statement, I need an S to indicate that there are some blonde people inside the class of blonde people who are not beautiful things. What happens if I take this X and I move it inside the circle P? Well, in that case, I would say that some beautiful things are not blonde people. But the O form is, in the O form, the X goes right here in the S, in the subject, in this case, in the blonde people. Okay, so these are the 4 forms. Now, these 4 forms have a quality and a quantity. So in logic, we call the quantity of a categorical form, what describes how many members are referred to. As you can see, category A form, and E form are universal statements. When I say that all members of S are members of P, I make a universal statement because I'm talking about all of them. Also, when I make a statement of the E form, I'm making a universal statement because I mean that no, not even one. So it's a universal statement. Not even one S is P. No S are P. On the other hand, on the bottom, you can see the I form and the O form. Those are particular statements. They are some S are P and some S are not P. These are the forms, remember, where we use the X. So since I am referring to some members of S in both cases, the quantity in this case is particular, universal and particular. Notice, by the way, that I arranged the four forms into in a square. Now this square is, we will learn later at the end of this lecture, is what is known the square of opposition. And we are going to learn two versions, two interpretations of the square of opposition, the traditional one and the modern one. But before we get there, we have to understand these concepts. Okay, let's go back to the quantity and the quality. So the quantity can be universal or particular. A and E are universal, I and O particular, because they make particular statements. Also, these forms have a quality. Now, the quality is whether they affirm or whether they negate. And you can see that A and I are affirmative. They both say something affirmative about the subject. All S are, some S are. On the other hand, the E form and the O form negate. They say something negative about the subject. No S are and some S are not. Okay, the next topic that we are going to learn is distribution. By distribution, I mean the number of members that I am referring to. So the proposition, for example, all senators are citizens, refers to all senators, not to one or to many or to some, but refers to all of them. All senators are citizens. But naturally, not all citizens are senators. So distribution is concerned with how many members of a class are referred to. So a term is distributed when it is used to refer to all members of a class. On the other hand, a term is undistributed, we call it undistributed, when it is not used to refer to all members of a class. Let me illustrate what I mean. Let's take one by one all the categorical forms. Let's start with A. If you recall, A states that all S are P. Now, by S and P, we can mean, for example, bananas and yellow things, subject and predicate. So, all bananas are yellow things, but not all yellow things are bananas. As you can see, there are many other things that are yellow. Cabs, lemons, school buses, many other things, daffodils. So, the subject the subject here, bananas, refers to all bananas. So remember, if the subject refers to all of them, then the subject is distributed. But how many yellow things are bananas? Not all of them, because there are cabs, lemons, school buses, and so on. So not all of them are yellow things. I mean, not all of them are bananas. Because the class of yellow things contains not only yellow things, but also yellow bananas, which are yellow things. So the predicate here in this case, the yellow things, is undistributed. Let's look at the E form. The E form is very simple. How many members of, since I state no bananas are yellow things, how many bananas are members of bananas and are not members of yellow things? How many of them? All of them are not members of yellow things. And vice versa, how many yellow things are not members of bananas? All of them. So I refer to all members. Consequently, the subject is distributed and the predicate is also distributed. Let's talk about the I form. The I form states, some bananas are yellow. And remember when I said that if I have an X in the middle, I mean that some bananas are yellow things and some yellow things are bananas. Consequently, both the predicate and the subject are undistributed because I refer only to some, not to all. The fourth one is the O form that states some S are not P. So how many members of bananas are not members of yellow things? Only some, not all of them. Consequently, the subject is undistributed. But on the other side, we have the category of yellow things. How many yellow things are not member of bananas? Well, 0. They are all members of bananas. All yellow things are members of bananas. And all yellow things are members of yellow things. Consequently, the predicate term is distributed. Now, this is a helpful chart. You can pause the video if you need it, or download it from my website or my PowerPoint presentation. This lists all the quantity, the quality, and the distribution. As I always say to my students, do not try to memorize distribution. Think about it. It's easier to think about it. Ask yourself the question, how many members am I referring to? And that's a very simple question. And it's a simple answer. And that answer will tell you whether a term is distributed or undistributed. Okay, let's move on to the next topic. The next topic is a delicate topic. It's the topic of opposition. By opposition, I mean the logical relationship between any two categorical propositions, between A and E, A and I, A and O and E, whatever. All these relationships. So what are these relationships? Well, it turns out that there are only 5 relationships. Let me list one by one and explain these relationships. They're very important. The first relationship is contradiction. So two categorical forms are contradictories only if they cannot both be true and they cannot both be false. In other words, they must have, when they are related, they must have opposite truth values. Now, which two categories, which two forms are contradictories? The form A and the form O are contradictories. A is a universal, affirmative. O is a particular, negative. Naturally, if A is true, O must be false. Think about this. If all bananas are yellow, then it is false that some bananas are not yellow. If all are, then it's false that some are not. And vice versa. If some bananas are not yellow, then it must be false that all bananas are yellow. So if one is true, the other is false. And when the other is true, the other is false. But they cannot both be true, they cannot both be false. By the same token, the E form and the I form are also contradictories. If one is true, the other is false. Think about it. If no bananas are yellow, not even one, then it's impossible. It would be false that some bananas are yellow. And vice versa, if some bananas are yellow, then it is false that no bananas are yellow. So these are contradictories. So A and O and E and I are contradictories. The second opposition, the second relationship between two forms is when two forms are contraries. Now, to be contraries, only two forms can be contraries. And to be contraries means that these two forms cannot both be true, but they may both be false. So let me emphasize this. Contraries are two forms that cannot both be true. By logical necessity, they cannot both be true. If one is true, the other one must be false. However, if one is false, the other one is not necessarily false. They may be false. It's a possibility. So it is a necessity that they cannot both be true, but it is a possibility that they may both be false. These two are the proposition of the form A and the E form. The A form and the E form are contraries. Don't get confused with contradictories. These are contraries. Contraries cannot both be true, may both be false. Let me give you an example. If all bananas are yellow, then it is impossible that no bananas are yellow. So if one is true, the other one must be false. They cannot both be true. Similarly, if I say that no bananas are yellow is true, then it must be false that all bananas are yellow. They cannot both be true. But what happens if they are both false? Is it possible? Well, there is a possibility. I'm sure you know that there are, in addition to yellow bananas, there are also green bananas, and there are red bananas. So there are other different kinds of bananas. So since there are red bananas and green bananas, it is false that all bananas are yellow things. And it's also false that no bananas are yellow things. So they are both false. A and E may both be false. The next relationship, which I didn't label, that's a mistake. I was supposed to put a label. The next relationship, anyway, is a relationship between the particular statements. Okay, so the relationship between the universal statements is of contrary. So A and E, the universal statements, are contraries. On the other hand, particular statements I and O are sub-contraries. Sub-contraries means that they cannot both be false. So it's the reverse of the contraries. Sub-contraries cannot both be false. They may both be true. Suppose that, again, let's use the banana example. Since some bananas are yellow and some bananas are not yellow, both I and O can be true. It's not a necessity. In this case, they're both true because some bananas are yellow, some bananas are not yellow. However, they cannot both be false because if some are and some are not, if some bananas are, let me put it this way. If it's false that some bananas are yellow, then it must be true that some bananas are not yellow, because that's exactly what I deny by denying that some bananas are yellow. So the falshood of one implies the truth of the other. However, the truth of one may lead to the truth of the other. So they cannot both be true, but they may both be false. It is a necessity that they cannot both be false. By logical necessity, they cannot both be false. And then it's a possibility that they're both true. Okay. Number 4. Again, I have to add a slide that says number 3. I skipped number 3. So just not to get confused, let's go back. Okay, number 1 will be contradictories, which are A and O, I and E. Contraries are only the universal statements A and E. Number 3, sub-contraries, I and O. And number 4 is superalternation. Superalternation is the following relationship. If a particular statement, either I or O, those are the particular statements. So if a particular statement is false, by superalternation, its corresponding universal statement must be false. In other words, falsity travels upward. It goes up. Now remember, if the particular is false, the corresponding universal must be false by logical necessity, but not the other way around. If the universal is false, it doesn't imply that, this does not imply that the particular is false. Okay? So falsehood only goes up. So if I is false, by superalternation, by this relationship, it carries upward to the A proposition, the falsehood. For example, if it's false that some bananas are yellow, then it must be false that all bananas are yellow. Because if some bananas are yellow, if some bananas are yellow is false, means that it is not true that all bananas are yellow. So the I is false and the A form is false by logical necessity. Once again, ask yourself, for example, is it true that some judges are lawyers? No, it is false that some judges are lawyers. So if some judges are lawyers is false, it means that there are some judges that are not lawyers. And consequently, it is false that all of them are lawyers. Right? So falsity goes up by superalternation. By the same token, if I say that some bananas are not yellow is false, then it's going to be false that no bananas are yellow. Because if it is false that some are not, if the negation is false, this might sound confusing, but if I negate a negation, essentially by a double negation gives you an affirmative, okay? So it is false that some are not. It means that some are. And consequently, it's going to be false that no bananas are yellow. All right. And the fifth relationship is subalternation. This relationship is the opposite of superalternation. This relationship says that if a universal statement, now the universal statement, is true, then its corresponding particular statement must be true, but not the other way around. Now, by corresponding, I mean, obviously, I is the corresponding particular statement of A. All SRP, some SRP. These are corresponding statements. And E and O are corresponding statements. No SRP and some S are not P. Okay? So if the universal statement is true, truth always goes down, but it never comes back up. It only goes down. So if all bananas are yellow is true, then it must be true that some bananas are yellow. This is very simple. I mean, think about it. If all bananas in the world are yellow, and I take a sample of those bananas, namely some bananas. Now, naturally, if all are yellow, even if I take a portion, if I take some, by logical necessity, they are going to be yellow. So truth goes down. However, if I start with a true particular, I'm not entitled to, this does not imply the truth of the universal. For example, if some bananas are yellow is true, do I know that all bananas are yellow? I have no idea. It might be true. It might be true. Might turn out to be true, but I don't know that. Okay. Finally, let's talk about the traditional square of opposition. But for the traditional square of opposition, I want to make a separate video. So I'm going to end here for the first video. Stay tuned and watch the second video for this traditional square of opposition and the modern square of opposition. Thank you for watching this video. I will see you soon next time.